So we're going to talk about transversals and parallel lines. So as we start to enter into geometry, we have to prove things. So before we talk about this, I want to highlight a few things. First of all, a straight line is an angle. And the angle of measure, if I go from this to this, it's 180 degrees. So a straight line has an angle of 180 degrees. Okay? Keep that in mind. It's important. It's going to be important for what we're going to do today. We're talking about parallel lines and a transversal. So parallel lines are lines that are, well, parallel. These two lines are parallel. In other words, A is parallel to B. That's what this little symbol means, parallel. Okay. And then T is the transversal. So the transversal is T. Now, a transversal is a line that intersects another line, or in most common geometry lessons, it's gonna cross a set of parallel lines, sometimes more than one parallel line. So what's interesting about that, there are some properties, and I'm going to explain all the formal math definitions of the properties, but usually in a parallel, and everything I write down, I want you guys to write down, usually in the parallel transversal world, it's some sort of angle, okay? And then I'm going to zoom in on this so you guys can see it a little better. But it divides everything into angles. So, in other words, this is a big angle, and this is a big angle. This is a big angle, and this is a big angle. So, big angles are congruent to all big angles. And that fancy symbol, the equal sign with the tilde on top, that means congruent. So all the big angles are congruent. We'll go through and talk about how and why, and they're going to tell us a bunch of properties. But the big angles are always congruent. Likewise, all of the small angles are congruent. All of the small angles are congruent. Okay? So the small angles are equal to each other. And I'll write an equal symbol. Okay? Now, lastly, if you notice, every big angle on the other side of the transversal, there's a small angle. Did you notice that? Yeah. If you look at it, wherever you see a big angle, on the other side of the transversal, there's a small angle. So, the big angle, the angle that's big, right, plus the angle that's small, what does it make up, though, if you look at it carefully? Like, let's hone in on something here. Like, look at these two, right? Look at these two. Oops, I hit the wrong thing. Look at these two angles. I'm going to highlight them in pink. What do those two angles add up to? A straight line, right? If I look at this big angle plus this little angle is a straight line. Well, what's the measure of a straight line? 180. So that means all big angles, when you have one big angle plus a small angle, it has to equal 180. So we'll say equals 180 degrees. Now these angles have names, all right? So let's figure out what they are. So we're going to mark them up with different colors, okay? So corresponding angles lie on the same line or same side of the transversal T on the same side of lines A and B. So they say angle 1 and angle 5. I didn't want to do it that way. Angle 1. Oh, it's not going to let me do it. So that means angle 1 and angle 5. Those are corresponding angles. Okay? 2 and 6 are also corresponding angles. 3 and 7 are also corresponding angles. 4 and 8 are also corresponding angles. Okay? Alternate interior angles. Interior that means it's inside of the parallel lines. So 3 and 6 are alternate interior. They're alternate because they're on opposite sides of the transversal, but they're inside the parallel lines. Do you see one other set of alternate interior angles? Yes. 7 and 8 are not on the interior. The interior is inside these two lines. So it's from here to here. 4 and what's on the other side of the transversal? No, they got to be trapped inside here. So interior is between this line and it's on the inside of these two lines. And alternate means they have to be on the opposite side of the transversal. The transversal is this line right here. This is the transversal. 4 and 5. Do you guys see that? So 3 and 6 and 4 and 5. And maybe I should write some of these down. So corresponding angles, alternate interior, so angle 4 and angle 5. What about alternate exterior angles? Well, now the exterior angles are the angles on the outside. So they say 1 and 8. So see how 1's over here on the outside of the parallel lines and 8 is on the outside of the parallel lines, but they're on opposite sides of the transversal T? Can you think of another pair of alternate exterior angles? How about angle 2 and angle 7? Does that make sense? Okay, same side interior angles. Now, same side interior angles are just on the inside. So they're 3 and 5. They're on the same side of the transversal. Can you think of another pair? 4 and 6. You guys are getting the hang of it. So those are the definitions. Now, each one of those angles has a property. But that property is based on big equals big, small equals small, and big plus small equals 180 degrees. That's the easiest way to remember it. So we're going to look at some of these angles, and I'm gonna do this in Desmos, I think maybe. We'll do a video, and we'll do it separately. So I'm going to pause the video here, and then I'll pull up a thing in Desmos, and then we'll do an activity in Desmos tomorrow, okay? So let me just save this real quick.